Okay, on this example number 2, slight different from the previous example. Here we have a sort of a chart as well, but you can say something else like trolley, okay? But it is on an inclined plane. And here we have a cabinet which 80 kilogram, and these whole things here are allowed. This whole chart or the cabinet together here is allowed to roll down this inclined plane, and we need to determine the acceleration of the cabinet as well as the reactions on the pair of rollers at A and B. To simplify our problems, we neglect the mass of the wheels for now. Okay, and on this particular figure, there is no external force involved. However, what we have here is only the mass of the cabinet, which going down like that. Okay, it is the weight, which is equal to mg. Okay, now to make our life much easier, we can say that we can draw our reference axis, okay, and like that. And it is our y, and it is our x direction going that way. This x here is parallel with this inclined plane. Okay, now since we know that the wake is pointing towards the ground, and there will be the x and y component of it. Okay, the y component is going that way, and the x component is pointing that way. Sorry, let's put it as okay, that's okay. Let's say this is our y and it is our x, okay, where we can say that fx is equal to w, and from here we can see that the angle is here. Okay, there is 15 degrees, so omega cos, oh sorry, for the x direction it should be sine. Okay, it should be sine. Sine 15 degrees, and the Fy is equal to W cosine 15 degrees. Okay. Okay, now we resolve the x and y axis, or we can denote as x dot or y, sorry, x prime or and y prime, because sometimes we want to we normally use the x and y like that, and we want to have a difference between the common representation of the reference axis. So that's why we put a x with a prime and as well as the y prime here. Okay, just to make it a little bit different. Okay, now in the x direction, what we have is the forces in the x here, Fx going downwards or going to the left And from our axis system here, going to the left is positive. So it's going to be, it is our M, it is our G. So W is equal to mg. And then as we have up here, it is multiplied by the sine 15 degrees for the x component. And then that will equal to the mass of the system, and then multiplied by the acceleration of this cabinet, I would say, okay, in the x direction, this direction, that particular direction, A. Okay, and from here we can resolve, and we get A is equal to 2.54 meter per square. Sorry, 2.54 meter per meter square. Sorry, A is equal to 2.54 meter per second square. Okay. And now, moving to the y component, what we have here is the normal force, okay, okay, at B and A. And here it should be 90 degrees. Should be 90 degrees. Okay, the normal force here, and also the Fy in this direction. We already have the Fy is like so, which is Fy is equal to, this is our Fy, this is mg, and this is cosine 15 degrees because going down, and y it is negative because it's the direction of the Fy is going downwards, so it is negative. And we have NA and NB is pointing upwards, so both are positive. And that is equal to 0 because the acceleration in the y component is 0. Okay. Note that if you solve the problem using this particular axis or reference axis, then the whole calculation will be different. Okay, definitely the things will get different. Okay, it's depend on your reference axis anyway. Okay, moving on. We know that this is point G, center of mass, and we want to calculate the moment about this particular point. And as we know that this trolley together with this, this cabinet together with the trolley on this incline are not going to have any rotation. It's just sliding down, and therefore the moment, the summation of moment is equal to 0. So now, as we assume that counterclockwise is positive, as here, so we can calculate the moment at forces at NA, and A is going that way, and therefore we will create a positive. It is counterclockwise, so it is positive, and the perpendicular distance is 0.5. Okay, it's given here. And then how about the B and B? It's the same, but from the forces at NB, it will create a clockwise motion. So it is a negative, and the perpendicular distance is 0.5. Okay. is given here, 0.5. And everything here is equal to 0. So now from here, we can see that we have one equation up here, and then another equation here. Therefore, we can solve the problem because we have two unknowns and two equations. And it is our reaction force on both wheels. And they are the same. Thank you.